You are not limited to Python as a programming language if you want to work with Spark. Spark also provides a Java API which allows you to do the same things with Spark that you can do with Python. So far, all our examples have used the Python API for working with RDDs. Python is a great programming language. It's very easy to pick up, and Python also lends itself well to data analysis and quick iterations and scripting. However, this may not fit all needs. Sometimes you may want to use Java to write your programs while working with Spark. You may have a very complicated system. You may want to express it using class hierarchy. You may want type safety in your language. If these are your needs, Python will not satisfy them, which is why you would use the Java API. The Java API is very similar to Python, and all usual operations, map, filter, etc., are available in Java as well. All the operations that you've learned so far work in Java. So you can simply apply them just in a different programming language. An essential part of dealing with RDDs in Spark is the use of the Lambda function. In Java, the function object is used to represent functions which will operate on all records in the RDD. These function objects are passed to map, filter, reduce by key, reduce, and all of these other RDD operations. Wherever we've used lambdas earlier, we'll now use function objects. In order to see how Java works with the Spark APIs, let's go back to the flight delays example. This time, we'll use Java to manipulate the data rather than Python. And all the subtle differences in dealing with Spark, dealing with data between Java and Python will come through. In order to work with Java, you have to set up a Java class. That should be no surprise to anyone who's familiar with Java. All the code that you write is within a class. What you see on screen is a class which parses the rows of the airports file. If you remember the airports file, which has a mapping from airport ID to airport description, it then creates a pair RDD for looking up the airport description given its ID. We first parse rows. The class is called parse rows, and all our code is enclosed in the main function of the class. In Java, the main function, the static void main function, is the entry point to our code. We simply put all our code in there using whatever helpful methods we need along the way. If you have objects and other entities that you need to represent your information, you can set that up as well. This is a fairly simple implementation in Java. We don't use additional classes or objects. All our code simply lives in the main function. The very first thing that you do in your Java code is the very first thing that you did in your Python script as well. We set up the Spark context. Remember, the Spark context represents a connection to the Spark cluster. You can write a whole bunch of Java code, but if you want to use Spark, you need the Spark context. Set that up in the first few lines of your main function. The Spark context needs a Spark config, which specifies the configuration parameters the context should use. The Spark config here, we've only specified the app name as parse rows. You can set up the cluster manager or master as we've called it back when we wrote the Python script. You can also specify the app name as we've done. And here is the Spark context object or the class new Java Spark context, which takes in a config. Once we have the Spark context, we're good to go. We can use it to create our RDDs. Let's set up our first RDD. We want the airports data. We set up our RDD from the airports.csv file. We simply call sc.text file, specify the path to the airports.csv file to create our airports RDD. This is identical to what we did in the PySpark shell as well as the Python script. What is really different is that the airports RDD now has a type. It's of type Java RDD with the generic parameter string. The Java RDD is a generic class with one type parameter, and you have to specify that type. That type represents the type of every record in that RDD. The airports RDD, when we create in this way, is a record of essentially lines where every line is a string. Every line contains information which has an airport ID and an airport description. But that entire record is a string, which is why the generic parameter for this Java RDD is a string. It represents one record, the generic parameter, the type of one record. The airports RDD is now available to you in the airports variable. You can simply apply all the transformations and actions that you're familiar with on this RDD. Whether you want to map, filter, reduce, aggregate, or any of the other transformations and actions that you can think of. All of them are available exactly like in the PySpark shell or your Python scripts. All of these operations have one thing in common. They need a function that will be applied to all the records of this RDD. In Python, we simply passed in a lambda function because that's a very natural way of doing things. In Java, this needs a function object. What is a function object? An implementation of the function interface, a class which implements the function interface. In Java, you have a choice as to how you want to set up this subclass of the function interface. You can create an actual subclass which implements the interface and implement every method that that interface provides. It's actually just one method, the call method. Or you can do it the quick and dirty way. You'll simply use an anonymous function class. You'll new up the class on the fly and pass it in to any of these operations. Or if you're using a more modern version of Java, you'll use lambda expressions. Lambda expressions are similar to lambda expressions in Python. They now exist in newer versions of Java. We'll see an example of all three types of function objects in just a bit. Let's start off with a subclass which implements the function interface. NotHeader is a class which implements the function interface. It has within it just one method, and this one method filters out the header row in the records. This is something we did in Python as well. Spark functions need to implement this function interface. Note that the function interface is a generic interface and it has two type parameters. The function interface takes in two type parameters. The first one we specified as a string and the second one as a boolean. So what do these map to? The string type parameter, the first type parameter, is the input to the function within this interface. Remember, this interface just has one function. These are called function objects in Java. An interface with one function is a function object, and this first parameter specified is the input to this function, the type of the input. The type of the input matches the type of a record in the RDD. So the airports RDD, remember, is an RDD where every record is a string. It is a string RDD. The NotHeader function object, which is the NotHeader class, has a method which is going to operate on every record in the airports RDD. Every record is a string, and the string is the first type parameter. The second type parameter is the return type of the function. The return type of the function in the case of the filter operation, remember, is a boolean. The filter operation requires a function which gives it yes if the record should be included in the result, or no if the record should be excluded from the result. So the return type of this function object should be a boolean, and that is the second type parameter in the generic interface. The function interface has exactly one method within it which needs to be implemented. That's why this NotHeader class is also called a function object. A function object is a class which implements an interface with just one method. All functions should implement the call method. And within the call method is where the logic of the function resides. Check that it takes in an input s, which is a string, and checks whether it contains the description string. If it does, that means it's a header row, and we return false to exclude it from the resulting RDD. Notice that the call method in the function interface that we implement has an input type and the return type which matches the templated parameters that we've specified while implementing function. The function's type parameters, it takes in a string and returns a boolean. That's what we've specified in the type parameters, and that's what the call method accepts and returns. An object of the not header class is the function object that we'll pass in to the filter transformation. Airports.filter takes in a new not header, an instance of the not header class. That is the function object. Let's now see an example of a function object created using an anonymous class. So after airports.filter, which used a subclass of the function interface, our next example will use an anonymous class. Here, we want to create an airports parsed RDD from a filtered RDD, the one which has no header row. The header row has been filtered out. This is a map transformation using an anonymous class. Let's start off by looking at the type of the airports parsed RDD which we get as a result of this map transformation. It is a Java RDD once again, but every record in that RDD is a list of strings. So this map has parsed the row and it has split it into a list of strings where the first string is the airport code and the second string is the airport description. Every record is a list with exactly two elements. The first is the airport code and the second the airport descriptions, which is why this Java RDD has a type list of strings. The parsing logic to convert a record which is a string to a list of string is enclosed in an anonymous class. Note, this class has no name. We've instantiated it on the fly. This class implements the function interface and is a function object. The function interface, as usual, has two type parameters. The first parameter is the input to the call method. The function operates on a string RDD, which is why the first parameter is a string. The function converts the strings into a list of strings. Every string is converted to a corresponding list of strings. That is the return type of the function, the return type of the call method in the function interface. The logic for getting the airport records as a list of strings is present in the call method, and here is the signature of the call method. Note that the input to the call method is a string and it returns a list of strings. It exactly matches the type parameter specified in our anonymous class. And here is the logic. There's a lot of it going on there, but the objective is to take a string, split it on the comma, and return a list of strings. That's all this code does. This is an anonymous class. Anonymous classes are great when you plan to use and throw, meaning you plan to use this class exactly once. You don't need to reuse it elsewhere in your code. If you do need to reuse it, you'd give it a name and use it as a regular class. The last option to pass in function objects is using lambda functions. Lambda functions were introduced in Java 8. So if your version of Java is older, this will not be supported. Lambda functions can be used for Spark operations and in fact allow you to specify functions in a very concise manner. Take a look at the map operation that we apply on the filtered airports. This operation transforms an RDD of strings into a numeric RDD of row lengths. We want to find the length of every row. Note that we take in S, which is one record in the input RDD, and then just return s.length. The lambda function is very similar to the Python lambda functions. And note that the return RDD has a generic type of integer. These are the three ways that you can specify function objects to use with your transformations: subclasses, anonymous functions, and lambda expressions. We are almost done with step 1 of our objective, to parse the airports.csv to get an RDD which has the airport code and the description. We already have the airport parse RDD. We can print it out to verify that we've got the right information. Here, we are simply iterating over the airport's parsed RDD. Notice that we use the collect action, and then we print out the elements in the list separated by a pipe operator. Step 1 is complete.